Good morning from NASA's Johnson Space Center. This is Mission Control Houston. You're looking at the International Space Station Flight Control Room on this Thursday morning, September 19th, 2013. A team of flight controllers watching over systems aboard the International Space Station as this team has been on console since early this morning, being led by Flight Director Mike Lammers. He is joined on console by Leslie Ringo to his right, who is handling the communications link between this team and the crew on board the International Space Station. That crew of Expedition 37 is comprised of Commander Fyodor Yurchikhin, along with two flight engineers, Luca Parmitano from the European Space Agency, represented by the Italian Space Agency, and U.S. astronaut Karen Nyberg from the United States. Obviously, these two crew members, along with Commander Yurchikhin from the Russian Space Agency, representing Russia, of course, have been in space now for, they're on their 114th day aboard the International Space Station after their single-day launch to rendezvous on their Soyuz spacecraft known as a TMA-09M vehicle back on May 28th. They plan to return home on November 10th after 166 days in space. They have focused their attention today on experiment work, focusing around the human research facility of the station with blood and urine sample periodic taking, along with some additional ocular health for the crew members and some ultrasound training for the crew members, along with some data takes in support of the ongoing efforts to understand how the human body reacts to the microgravity environment of space and changes over long duration periods of time. The crew members also have performed some routine housekeeping chores around the station and have also been updated on the progress of a new cargo vehicle on its way to the International Space Station. Orbital Sciences Cygnus spacecraft launched just before 11 a.m. Eastern Time on Wednesday on a trajectory profile to the southeast that puts it in line in the same plane, if you will, with the International Space Station, leading toward an arrival and berthing to the complex's Harmony Nadir port, the Earth-facing port on the Harmony node, on Sunday morning, with a targeted berthing time of just about 6:25 a.m. U.S. Central Time. All parameters on the Cygnus are in excellent shape. The vehicle has performed a number of tests on its way to the station over the course of the several days, including so far a position and attitude control test, a free drift test, and an active abort demonstration. All of those proves the navigation of the spacecraft using a global positioning system, and also puts it in good shape to support that rendezvous activity. Over the course of the next several days, a continued series of rendezvous maneuvers will take place using thrusters on the cargo vehicle before it arrives at the station in the wee hours on Sunday. So the crew on board is also getting ready for its arrival with an installation of the robotic workstation software to follow along and be ready for the robotic capture that will be handled primarily by Luca Parmitano aboard the station. So the crew obviously staying very busy on board and greatly anticipating the arrival of that new cargo vehicle, the first ever space station mission launched from the coast of Virginia at the Wallops Flight Facility. On the shift prior to the current flight control team on console, Courtney McMillan was the flight director overseeing that team. She has served as the lead for this Cygnus demonstration mission to the station, so probably been working this mission for a couple of years as the lead flight director. So she will be on console. She's adjusting her circadian rhythm schedule to support the overnight shift, which effectively is the first shift for the flight control teams, as that's aligns with the shift that the crew wakes up on, and also with the shift that the Cygnus rendezvous will take place, as you saw with some of those times that for our coverage that we plan to have end-to-end coverage of the Cygnus rendezvous and capture of the vehicle by the station's robotic arm. That robotic arm you see there on the outside of the International Space Station, it's a very unique capability with this robotic arm, as that both ends are actually powered, and so are the grapple fixtures on which the end effector is currently grappled as well. That allows for the robotic arm to be maneuvered to various locations on the station to support robotic activities that can be controlled from crew members inside. Parmitano plans to control the robotic arm from the cupola, which is the provides a 360-degree view around the station for situational awareness for crew members, and they also have, of course, computer screens in front of that workstation to allow for the precise maneuvering of the robotic arm as well. The station currently is flying just about to cross the state line of Illinois on a southeasterly swing that will take it above the Midwest, just to the south of the Great Lakes region, across Indiana, Kentucky, North Carolina, and then out across the coastline, heading down across the Eastern Caribbean, skirting Puerto Rico, and then heading down across Brazil before swinging out over the South Atlantic. From this vantage point, the station, at its current altitude of 260 statute miles, is circling the Earth every 92 minutes. The Cygnus spacecraft, which of course is chasing the space station right now, is in a little bit of a lower orbit as of 1 a.m. Central today. The Cygnus was in an elliptical orbit of 239 by 214 statute miles. That's about 385 by 346 kilometers. The current updates on trailing distance of the station is about 4,400 statute miles, or 7,100 kilometers. Of course, the lower altitude allows the Cygnus actually to catch up with the station from behind following Wednesday's launch, and the series of rendezvous maneuvers that will take place over the course of the next several days will, in a very structured way, raise the Cygnus's altitude to the point where it eventually will match that of the International Space Station, so that at the time of the berthing or capture, the relative motion of the two vehicles will essentially look as if they're not moving at all, when in fact both continue to move at an orbital velocity of about 17,000 miles per hour. Just to clean up some of the parameters relative to some of the what's known as the delta velocity burns, or the rendezvous maneuvers of Cygnus following its launch. As you recall, the launch was delayed by about 8 minutes from its original targeted launch time. The launch took place at 10:58 a.m. Eastern Time, and that caused some adjustment to the rendezvous maneuvers. The first delta velocity, or DV1, or rendezvous maneuver, took place Wednesday afternoon after the launch, and it actually was adjusted after that changed launch time, so it was a burn of 6 minutes 17 seconds, which changed the velocity of the vehicle by 77 miles per hour. The original plan was for that burn to last a little bit longer, about 20 seconds longer, and be a little bit larger burn of 96 miles per hour. So obviously real-time adjustments are the name of the game in the space business, especially with rendezvous, and the trajectory team, the flight dynamics teams recalculate all of the burns in order to retarget all of the rendezvous maneuvers, continuing to target the same berthing time. The next rendezvous maneuver occurred this morning just after midnight Central Time at 12:54 a.m. That burn originally was almost a 5-minute burn of 69 miles per hour, but the actual today was 2 minutes 59 seconds, changing the Cygnus velocity by 43.7 miles per hour. And the clock, there's a clock here in Mission Control that's counting down to the next in the series of those burns. The DV3 burn is targeted for 11:52 a.m., about 1 hour and 42 minutes from now. Originally a 6-second burn. This was supposed to be a very small burn. Now has been adjusted to be a little bit larger burn of 2 minutes 44 seconds, and a change in velocity of about 40 miles per hour. So as you can see, the team has adjusted some of those burns, but the end game is to target the original capture time of 6:25 a.m. Sunday morning Central Time, 7:25 Eastern Time, with all of the activities associated with that rendezvous, the go, no-go for joint operations occurring in the wee hours just after midnight Sunday. That's when all of the joint targeting reference point activity associated with the rendezvous begins. With any new visiting vehicle such as the Cygnus, and also desired by not only the space station team but also the Orbital Sciences Corporation team as well, to prove the capabilities of the vehicle to rendezvous and even to abort a rendezvous if that were required for any reason. So there's a series of tests that will be performed primarily during that final stage of rendezvous on Sunday morning. There is are several maneuvers to prove the capability of the vehicle to abort a rendezvous should that become necessary. And all of that's pretty much automated, putting the vehicle finally in a position about 10 meters or about 30 feet or so from the space station, so that at that point Luca Parmitano, with assistance from Karen Nyberg on the robotic operations, can reach out and capture the Cygnus spacecraft via a grapple fixture on that vehicle that will then allow them to berth it to the common berthing mechanism on the nadir port, or the Earth-facing port of the Harmony module of the International Space Station. That port recently vacated by the Japanese cargo vehicle HTV-4, the Konotori 4. The three crew members on the International Space Station also are preparing for another visiting vehicle, that being the arrival of the next Soyuz spacecraft, a Soyuz TMA-10M spacecraft, which will deliver 3 new crew members to the International Space Station. Oleg Kotov making his 3rd flight into space and his 3rd long-duration voyage to the station will command that Soyuz spacecraft. He will be joined by his Russian cosmonaut colleague Sergei Ryazanskiy on his first voyage into space, and U.S. astronaut Michael Hopkins also on his first flight into space. Those 3 are at the Baikonur Cosmodrome in Kazakhstan, preparing for their launch to the station, which is scheduled to occur next Wednesday, the 25th. With their current launch time of 3:58 in the afternoon, U.S. Central Time. on a single-day launch to rendezvous profile, putting them at a docking with the station late in the evening, currently targeted for about 11 or about 9:48 p.m. docking after a 4-orbit launch to rendezvous profile, and then the hatch opening you see there late in the evening, just before midnight. So as mentioned, these 3 crew members are at the Baikonur Cosmodrome. They traveled to Baikonur this past Friday to prepare for their launch, or earlier this week, and to prepare for their launch. And they're in the final days of their training, and obviously reviewing all of their plans for their 6-month stay aboard the station as well. So let's take a look at the newest 3 crew members that will be heading to the station to augment Expedition 37 next week.
Aiding the pursuit of knowledge is a top goal for the 3 newest members of the International Space Station's Expedition 37 crew. Dr. Oleg Kotov is a native of Simferopol in what is now Ukraine. But as the son of a Soviet military officer, he grew up all over Russia and had his sights set on the military for his own career by the time he finished high school in Moscow.
I decided to become a military officer as well, like my father, my grandfather. However, I kept dreaming about space, and while I had to select my major, I was very careful about it, and I became a military surgeon in the area of aerospace medicine.
After graduation from the Kirov Military Medical Academy, Kotov went to work at the Gagarin Cosmonaut Training Center as a doctor, studying altitude physiology and the effects of spaceflight on the human body. At the same time, he studied diagnostics and methods of pilot selection and also earned a degree in patenting. In 1996, he entered Air Force Pilot School and was selected for cosmonaut training. He made his first spaceflight in 2007 and completed 2 spacewalks as a flight engineer on Expedition 15. He did another EVA during Expedition 22 before becoming commander of the station for Expedition 23 in 2010. Kotov then served as deputy chief of the GCTC before starting training for this mission, which presented another opportunity to fulfill the human instinct to learn new things.
It's a desire to understand the world around you, to expand the area where we live, to explore the space, Mars, Moon, other star systems. So it's a question about a desire to learn something new.
Dr. Sergei Ryazanskiy is a rarity among Russian cosmonauts, one who was born and raised in Moscow. As the son of engineers and a grandson of Mikhail Ryazanskiy, a leading Soviet engineer specializing in missile and spacecraft radio guidance, Ryazanskiy had his sights set on a career in science at a young age.
When I was a child, I wanted to become a biologist. So I was studying in a specialized school where we were majoring in biology, so I knew that I would be a scientist. I think I knew that since I was in the 6th grade. I knew that I would try to go to the Moscow State Universities,
where he graduated with a degree in biochemistry and went straight to work at the Institute for Biomedical Problems at the Russian Academy of Sciences. His specialization in ways to prevent the adverse effects caused by the absence of gravity got him involved in the space industry and sparked an interest in becoming a cosmonaut himself. In 2003, he was selected to join IBMP's Cosmonaut Corps and completed basic training at the Gagarin Cosmonaut Training Center. In 2006, he earned his doctorate in physiology and space medicine. And in 2009, he was crew commander in a 105-day-long isolation experiment known as Mars 500. By 2010, he was certified as a GCTC test cosmonaut, which he calls the most interesting job in the world because it combines so many things.
Anything you can think of is combined by this profession. And being part of this industry is very interesting. You have new technologies, new approaches, and you're always on the edge, so to say. You always know the latest developments. It's very interesting to live this life. It's very interesting to train for this life. That's why I became cosmonaut.
U.S. Air Force Colonel Mike Hopkins is from South Central Missouri, born in Lebanon and raised a few miles away on a farm outside Richland. He credits his small-town upbringing for his getting the chance to try everything in high school, not only football and other sports, but all school activities, and for developing his interest in engineering.
My father was a pilot in the Marines back in the early 60s. He flew A4s, and so there was aviation in my family. So that certainly piqued my interest in it and my interest in space. My desire to become an astronaut started back in high school.
Hopkins headed to the University of Illinois to study aerospace engineering. He also walked on to the football team and ended up as a starter and a team captain by the time he graduated with his bachelor's in aerospace engineering and a commission in the Air Force earned through the ROTC. After finishing a master's in aerospace engineering at Stanford, Hopkins began his Air Force career in a laboratory working on space systems technologies. Then he moved on to become a flight test engineer, even spending time as an exchange officer at the Canadian Flight Test Center in Alberta. In 2002, Hopkins won a scholarship to study political science in Italy, after which he was assigned to work in acquisitions at the Pentagon, and then as a special assistant to the Vice Chairman of the Joint Chiefs of Staff, the job he had when he was selected as an astronaut in 2009. He's the first member of his astronaut class to fly in space, and eager to use his mission to try to help satisfy our desire to learn.
Humans are always striving for knowledge, for knowing what's beyond the hill, for knowing how each little thing works in our world. Whether it's the human itself, whether it's anything within biology, the physical world, all of that, we have this desire to know as much as we can about that. And the space station, the International Space Station, fits right into that.
aboard the International Space Station. The crew members have passed the midpoint of their day. They broke for lunch about 8 o'clock this morning, remembering that they wake up about 1 o'clock in the morning each day. You can see Karen Nyberg and Luca Parmitano working aboard the station in the second half of their day, which ends with an afternoon teleconference with all the flight control teams around the world to tag up on what they did today and look ahead toward tomorrow's activities. They head to sleep about 4:30 in the afternoon, and then they'll wake up again on Friday about 1 o'clock in the morning as well. The flight control team is continuing to watch over the station systems, everything in great shape for the crew on board the complex. Karen Nyberg is a flight engineer aboard the station. This is her second flight into space. She flew on a space shuttle mission, but this is her first long-duration stay in space. Periodically, she had an opportunity to talk about various aspects of her career, her life, and one of those focused on career choices that she's made to get her where she is in the spaceflight business. Let's take an opportunity to visit with Karen Nyberg about career choices.
What made you pick mechanical engineering?
It was the most, I think mechanical, I think I'm very visual, and to me chemical engineering was not visual, electrical engineering was not visual, but mechanical for the most part, although then I started studying heat transfer, which ended up being my favorite, and that part of it is not visual, but you know, originally looking at all the disciplines of engineering, mechanical was the closest to the way my brain thought at the time. And we did not, I may have chosen aerospace engineering, but the University of North Dakota did not have that as an option, which I think is fine, because I think a mechanical engineering base can take you a lot of directions and obviously can go to the aerospace or biomedical area. So, but mostly I think it was because of the visual nature that at least I anticipated it would be at the time when I chose.
So does that mean that when you have time, you're good at fixing things, like at home?
I can, yeah. I don't know if, you know, I don't know if I'd qualify myself as good at it or not.
The fact that you can. Well, you know, I actually really never knew that about myself, because in my family, we called somebody. They came, they fixed it, and it really wasn't until I was training for station that I said, oh, using tools, it's just not that hard.
Yeah.
And fixing things,
exactly.
just not
well,
that hard.
I remember the first time I changed a tire on my car, and in fact, I was an undergraduate student at the time, and my car had a flat tire, and I'm at my apartment, and I have to do something. I was like, well, and I remember some of my friends, well, why didn't you call us? There's directions. You know, I followed the directions, and I was surprised how easy it was. This is really, really simple to change this tire. And why didn't I do it when I was in high school? I could have. You know, it's that simple, but it just wasn't something I did. And I wouldn't say that I've done a lot of fixing things. You know, a lot of times it's the balance of, do you have the time to do it, or the money to pay somebody? You know, even though you have the capability to do it, you just don't, because there's other things you'd rather do. But I feel that I could, if I needed to, a lot of things.
I mean, the fact that you're up there fixing things on the space station, I mean, things break, things need maintained, and the fact that you're up there doing it with your hair all big and wild is really going to speak to a whole generation of girls who are just going to think it's really normal to be the one that fixes things.
That's great. I think that's great. I hope that what we do in space can reach those girls that may not think that that's a possibility.
What do you think it'll be like to be the only woman on the crew?
Well, I was, you know, for STS-124, and actually having started engineering when I was 18, 19 years old, I was always one of 20% or fewer females, oftentimes the only girl in the class, sometimes one of 2 or 3 girls in the class. My engineering graduating class, I don't know, somewhere between 15 and 20% of us were females. And so it's just normal to me. It doesn't seem unusual. And I think just because, you know, starting at that age, I was, in groups where it was mostly boys or men, it doesn't seem unusual to be a part of a crew that I'm the only female. It's kind of standard for the way I've known things to be.
What do you think girls today need to know that they don't know? Like, what would you encourage them about?
I think it's important that girls know they can be the fix-it person, the smart person, and still be a feminine person. They can still enjoy girl things. You don't, just because you like girl things, to sew, you like pretty dresses, whatever it happens to be, you can still be the smart person who can figure things out and who can get dirty and fix things. And you don't have to be one or the other. There's a combination that you can be. And I think that's important for girls to know that. There might be a perception that if you choose engineering, you're giving up something. I don't know. And I hope that girls don't think that. But if they do, I would like to be able to show them that you can be both. It's possible.
What about having a family? Do you think you have to choose?
No. I don't think you have to choose. I think it's important that you have, that your husband is obviously on the same page and believes the same way that you do about it and supports what you're doing. But I think absolutely it can work. You can be a supportive mother, be a good mother, and still have the career that you dreamed about having.
That's Karen Nyberg aboard the International Space Station before her flight, obviously talking about, in this case, career choices. Everyone obviously makes career choices as they go through their younger years, and then when they get into school and college, obviously. And so that's an interesting discussion that she had with another astronaut, Katie Coleman, about what her decisions were that led her to where she is now, 260 miles above the Earth, aboard the International Space Station. Also, we have an opportunity and a pleasure to welcome Heather Paul into the room. Heather is a Crew and Thermal Systems Division lead for strategic communications here at JSC at the Johnson Space Center, and the engineering directorate, right? And Heather is taken. I'm really pleased to have her come and join me. Thanks, Heather, for coming.
It's my pleasure. Thank you.
We just saw Karen talking about career choices, and I asked Heather to come by and talk to us about her own career choices and how she got where she is. So I'll let you start by just tell us a little bit about how you got interested in space in the first place.
Sure. Well, my interest in space started when I was actually a very young child. I was one of those kids who was always asking if I could go outside to go look at the stars. And I loved looking at the moon, the stars, trying to figure out where the constellations were. My favorite constellation is Orion. It's the easiest one for me to spot in the night sky. And really that interest in space began with that kind of astronomy interest, but then it grew as I learned more in my science classes about black holes and the planets. And my favorite thing to draw when I was in art class was the solar system. So while all of my friends were drawing homes and their pets, I was drawing the sun and all of the planets in succession. So it really is something that I think I was destined to do, to come work in the space program and help us develop technologies that we can use to live and work in space.
So you really thought that as a young age. You said, I really want to work, so young people sometimes don't make those decisions that early on in their careers. But when you got a little older, did you start trying to look at, in terms of education, you can talk about your educational background, if you made the choices that would lead you specifically here, but did you make set any professional goals for yourself, even as a young age?
Well, that's an interesting question because I actually grew up in a very non-engineering type family, and in fact, I could dance before I could walk. So I have a very artistic and creative side. I've danced all different forms of dance. I played piano and clarinet. I sang. I won't sing for you today because now I'm terrible, but when I was young, I had a wonderful voice. So I really grew up in this very artistic family and foundation. But when I was at school, as much as I loved my arts classes and literature, I really had this strong affection for math and science, and I really was drawn to those subjects in such a way that I wanted to figure out what I could do with that knowledge. And of course, then my interest in space, I thought, well, I have to be an astronaut. And then I started getting older and realized that that's pretty competitive. And I said, okay, well, I'm still going to shoot for that goal of living in space, but what's the next best thing I can do? Be an engineer. And that's what I really strived to do throughout my education, is figure out what classes I needed to do to become a really good engineer for NASA and maybe one day an astronaut like Karen.
Right. I think that's what a lot of people, they strive to be. They think, I want to be an astronaut when I grow up, but there's so many different fields, certainly in the aerospace fields, specifically here at NASA, and even more specifically here at the Johnson Space Center. There's so many different career fields that put you directly involved in what happens on that International Space Station right now. It's quite intriguing, but now talk a little bit about specifically how you ended up at NASA, and I guess your whole career's been here.
Yes. I've worked here for 18 years now. I just celebrated last week my 18-year anniversary, so I'm excited to say that I am a late teen in my NASA years. But I actually started out here as a student. So when I was majoring in mechanical engineering and Spanish at Auburn University, I was one of the lucky few that got a job here as an undergraduate student, and I was able to alternate between going to school for a semester and then coming to work at NASA, and it was an amazing way to get a better understanding of all of the theories and all my homework and design projects that I did at school, how I could apply that to not just engineering projects, but engineering projects that were going to fly in space. And so I was able to take a stroll through life sciences for a while and learn how the body is affected by microgravity. I spent a lot of my time in our engineering directorate designing space station tools and hardware and evaluating spacesuit materials. I was a rocket scientist for a very, very brief time, realized that my experience does not lend well to propulsion techniques, so I'm going to leave that to the experts there. I also was in mission operations for a while, learning how to work in a place like the flight control room here to help the astronauts while they're doing their day-to-day operations.
Right.
But my true love is really designing hardware for the astronauts to use while they're on board the space station and for future exploration.
And you, as you mentioned, you've worked in a lot of different areas. Diversity in your portfolio or your professional portfolio, some people want to focus on one thing for their whole career, which is great, and some people want to work in different areas and get a diverse background, and I think that's a good example of that, and the opportunities could be endless in terms of where you can go with the educational background that you have in particular, right?
Absolutely. In fact, when I was a student here, as I mentioned, I could kind of hop around. Once I've settled into my current role in Current Thermal Systems Division, even within our fantastic team, there are so many different opportunities for projects, whether I want to work flight hardware that's on board the station now, or even sometimes more exciting, looking at what we can do to design hardware if we go back to the moon, onto Mars, or explore an asteroid. And as you mentioned, the diversity in careers, the diversity in opportunities is just as diverse, if not even more so. And as a mechanical engineer, even though that's my foundation in education, I've worked as an aerospace engineer, an electrical engineer, a chemical engineer, a lot of different opportunities with that mechanical engineering foundation.
And not only with that foundation, now Heather, obviously, she not only reaches out internally in the work that she does, but you also now do quite a bit of external work as well, associated with getting the word out about what we do.
Absolutely. I think that's a very important part of my job and our job at NASA is to not only make sure our astronauts are safe and working well on board the space station, we're designing all of these new technologies and partnering with industry and academia, but making sure that the kids today realize that this is something that they can absolutely do and we need you. I like to say, Kyle, that we at NASA are just normal people that get to do extraordinary things, and I think that's really true. I'm just a normal gal who happens to have a really cool job.
Yeah, that's great. We both feel the same way, obviously. What's next for you? I mean, you've already in 18 years have done so much. Do you have any other goal or anything new that you're headed toward?
Certainly, of course, my ultimate dream is to become an astronaut. We'll see if that happens one day. But if not, I'm actually really happy being a support engineer for our flight crew. And what happens next, you never know. I always like to look for new opportunities. I love working in the engineering directorate here, and in my specific division, we've got a fantastic team of people that are doing such great projects. It's always really interesting. But, there's opportunities all around the center, and, I'll stay tuned. Maybe I'll come back on and let you know.
Well, we'll look forward to that. And her favorite constellation is Orion. Of course, we're building an Orion spacecraft to go to deep space one day, and the commercial crew program is there to follow on the shuttle with a new crew vehicle to deliver astronauts to the International Space Station. So, along with a lot of other engineering activities that are going on around JSC, and not only here, but at other agencies or other centers around the agency as well. So, as you can tell from Heather, she's one of a lot of people that support what goes on not only here at the Johnson Space Center, but at NASA in general. And we really appreciate you coming by and talking to us.
Yeah, my pleasure. Any chance that I can get out and talk about the wonderful work that we do here, and more importantly, the wonderful people. It's just such a great family and such a great team, and it's my honor, absolutely, to work here.
It really is. It's a great bunch of people to work with, and all the flight controllers here, they all say the same things. And so, again, we appreciate you coming by. And that's Heather Paul. She's a Crew and Thermal Systems Division lead for Strategic Communications here at JSC. She's going to stick around and join me when we talk to some school children at the East Paulding Middle School that's located outside Atlanta and Dallas, Georgia. So we'll look forward to talking with those school children, the sixth grade science students, with their teacher, April Leachman, that class upcoming here just after the top of the hour. The station currently moving into an orbital sunset as it crosses what's known as the terminator, the point between sunrise and sunset. You can see the Cygnus spacecraft following the station, continuing its chase to catch up with the complex. And meanwhile, earlier today on board the complex, crew members continued their scientific experiment work on board, and Karen Nyberg, in particular, focused on the window observational research facility on the station, known as the WARF by its acronym, to assist in operating the station's iServe experiment camera, which is a acronym within an acronym that stands for ISS, Surveyor Environmental Research and Visualization System. iServe is basically a means for crews to help gather and help folks on the ground gain experience and expertise in automated data acquisition from the station. It's also used for helping and providing useful images for disaster monitoring and assessment, as well as environmental decision making on the ground. Periodically, this instrument is set up for use by the crew members on board and folks on the ground as well.
Huntsville Station on 2 for iServe.
Go ahead, Karen, on 2.
Yeah, I'm in step 5, and the pointing controller does not say CPC ready, press enter to begin alignment.
Copy. Give us a moment. And Karen, if you can just press undo a few times, see if you can get back to that menu. If not, just press on.
Okay, that worked on there.
Copy.
And Huntsville Station on 2 for step 6.
Go for step 6.
Okay, it says that I should expect menu tracking. I see menu scope setup. Oh, I see step 9. That's what we want. So I guess I'll skip on to step 9. Or step 8.
We're checking, Karen. Karen, you have to go to proceed with step 8.
Okay, copy that. And also, I had accidentally pushed a down arrow button, and I heard it sounded like the pit adjusted slightly when I did that. Is there some way I should, is that going to make it in an incorrect position?
You can press on. That shouldn't impact anything.
Okay, copy. Barnesville Station on 2, step 21, the eye surface ready for the ground commanding.
We copy, Karen. Good.
That was just one of the activities for Karen Nyberg aboard the International Space Station today. The crew members are each have exercise scheduled in the for the afternoon part of their day before they gather together for their afternoon daily planning conference. That's the long-distance teleconference with all of the flight control teams on the ground. That's scheduled for just after 1:30 this afternoon Central Time. And the crew members will then pretty much be on their own for their last couple of hours before they head to bed. They will finish up video downlink work with the robotic workstation that will be utilized for the capture and berthing of the Cygnus spacecraft that launched from the Wallops Flight Facility on Wednesday morning. And the crew members are obviously greatly anticipating the arrival of that Cygnus spacecraft scheduled for the wee hours Sunday morning, with capture about 6:25 a.m. Central, 7:25 in the morning Eastern. Before we close today, a couple of programming notes. Stay tuned for the conversation with some school kids in Dallas, Georgia, which is off to the northwest of Atlanta. And again, Heather Paul, who joined me just a short while ago, will stick around and talk to the school kids and answer some spaceflight questions beginning just after the top of the hour. One more programming note: video file this afternoon at 2 p.m. Central, 3 Eastern will be some highlights of crew activities of the Expedition 37 and 38 crew as it prepares for launch from Kazakhstan at the Baikonur Cosmodrome next week on the 25th, so stay tuned for that. And we'll be back again here on tomorrow at the same time, 10 a.m. for another hour of coverage of Expedition 37. This is Mission Control Houston.